we are going to talk about momentum this time. So, momentum is a concept in physics where you have a sort of transference of kinetic energy between two bodies or two systems. And those two systems can either combine to form one system, or it can still remain two separate systems. So when a collision occurs and between two bodies, say we have a red body here and we have a purple body here, right? So say this red body collides into this purple body. So if the red body hits this purple body and they remain separate, they don't combine into one system, then we have what is called an elastic collision, where the transference of kinetic energy remains constant. So there's a conservation of kinetic energy going on. In a perfectly elastic collision, you have an equal transference of kinetic energy, and there's always going to be the same amount of kinetic energy, and there's also going to be a conservation of momentum as well. The law of conservation of momentum is always true for momentum problems, where it says that the momentum at the start of a collision is the same as the total momentum after the collision. And this is true for both elastic and inelastic collisions. And so an inelastic collision is when, well, it's the opposite of an elastic collision. The two bodies actually combine into one body. So we have this and that end up making a sort of combined system of a red and a purple body. And now that they stick together, the mass has increased. If you add up the velocities of these two, it should be greater than the velocity of the final body. And so that is because, although there is a conservation of momentum, there is a huge loss in kinetic energy because of the collision. An inelastic collision normally occurs due to some of the kinetic energy being turned into heat. And when I say some, I mean a lot. A lot of kinetic energy, almost 92.1% of energy in an inelastic collision is turned into heat energy. And it gives off heat, right? So it gives off heat. It bends the material together so they're combined and now they're one body, and that mass is greater, so the velocity has decreased because of momentum. Momentum, its variable is p, and so p is equal to mass times the velocity, and so p equals mv. And so when the mass increases, the velocity must decrease. And so therefore, when these two bodies collide, since the total mass increases, the total velocity has to decrease as well. And so here we have an example of an elastic collision. We have a 5 kilogram block moving at a velocity of 10 meters per second colliding with a block with a mass of 2 kilograms that is at rest. And so we want to find the final velocity after the collision of this body. And to do that, we start off with law of conservation of momentum, defined as P1, or the initial momentum before the collision must be equal to the total momentum after the collision. P1 is equal to P2. And so we separate this. So how many bodies do we have? We have 1, 2. We have 2 bodies here. And so since we have 2 bodies, P1 initial, we'll say this is actually P initial and P final, just because we have 2 bodies instead of 1. So P1 initial plus P2 initial is equal to P1 final plus P2 final. And so this is the expanded law of conservation of momentum, because we have 2 bodies here, and although it is an elastic collision, we still have to consider the fact that momentum is transferred, and there's always a conservation of this momentum throughout the entire process. So the initial momentum of the first body, we'll say this is 1, and we'll say that this is 2. So the initial momentum of the first body is just its mass times its velocity. So it's just m1 V1, V initial 1, V1 initial actually, V1 initial, plus, let's see, well, mv, right? The mass is 2, but its velocity, its initial velocity is 0. So it's just 0 is equal to P1 final, which we don't know. We don't know what its final speed is. Or do we? Remember that we're going to say that this is a perfectly elastic collision, which means that the velocity of the first block should be the same after the collision, because it maintains its momentum no matter what, right? No. Just because it has its energy retained does not mean that it still moves at the same speed. It cannot move at the same speed because then the law of conservation would not apply. There still needs to be a conservation of energy, but there also needs to be a conservation of momentum, and that conservation of momentum always comes first before you do a conservation of energy. And so instead of 0, we don't know what the actual final velocity is, like I said before. So we're going to say m1 v1 final plus, and then we don't know our v2 final, right? And so now all we need to do is just find both of these variables. Easy, right? Well, other than the fact that there's an infinite number of solutions to this problem, unless we bring in another equation. And that equation just so happens to solve for velocity, and it's v1 final minus v1 initial is equal to v2 initial minus v1 initial. V2 final minus v1 final. Like this. This is the equation here. And this is true always. So we have v1 final minus v1 initial minus v2 initial is equal to v2 final minus v1 final. Sorry. So this is always true, and so we're going to input this for here. So we know v1 initial and we know v2 initial. v2 initial is just 0. v1 initial is just 10 meters per second. And so v2, and since this is an elastic. This is an elastic equation. This only applies to elastic because of the conservation of energy. The velocities stay constant here, right? And so the v2 final minus v1 final, which neither of these we know, v2 final minus the difference between v2 final and v1 final, neither of which we know, is equal to 10 meters per second. Right? So v2 final minus v1 final is equal to 10 meters per second. And so we can solve for v1 final and input that here. And we can input that there, or we can just solve for v2 final and input that here. So we're going to do v2 final. v2 final is equal to 10 meters per second plus v1 final. Okay, we have that now. And so now all we need to do is just input v2 final, what we solve for, in there. And so we have m1, which is 5 kilograms, times v1 initial, which is 10 meters per second, plus 0 is just nothing, is equal to m1, which is 5 kilograms, times 10 meters, plus v1 final, plus, actually no, that was v1 final, times v1 final, plus m2, which is 2 kilograms, times 10 meters per second, plus v1 final. Alright, and so now that we know these, we have to solve for v1 final. So now we're just going to distribute 2 kilograms, and so we have 50 kilogram times kilogram meters per second is equal to 5 kilograms times v1 final plus 20 kilograms times kilogram meters per second plus 2 kilograms times velocity 1 final. So now we just bring out velocity 1 final. V1 final times 5 kilograms plus 2 kilograms plus 20 kilograms kilogram meters per second is equal to 50 kilogram meters per second. Right? And so now we just need to subtract 20 kilogram meters per second, and so we're left with 30, and then we just divide by 7. So V1 final is equal to 30 over 7 kilogram meters per second, which is about 4 2/7 meters per second, which is approximately 4.29. So we'll say 4.3 meters per second. So the final velocity of 1 is 4.3 meters per second. As you can see, the velocity has decreased here, right? The velocity decreased because it collided. And that velocity, because momentum has been transferred to the second block, we now have lost some speed in the first block. So here we have an example of an inelastic collision between two bodies. And so it's the same two boxes, but this time they collide with an inelastic. They collide inelastically, meaning that they combine to form one body. And so we're still going to use the law of conservation of momentum first to determine the final velocity of the second block. But in this case, really we're trying to find the final velocity of both blocks combined, because it's an inelastic collision and they combine to form one body. And so we start off with P initial is equal to P final. And so we have how many bodies? 1, 2. 2 bodies. And so we have P1 initial plus P2 initial is equal to P1 final plus P2 final. And so now we know what P1 initial is. It's just mass 1 times velocity 1 initial. So that's M1 velocity 1 initial plus the initial velocity of the body 2 is 0. So we have 0 is equal to 1 is equal to mass 1 times velocity final, and because they combine to form one system, they have the same velocity. And so we're just going to say velocity final because they combine to form one system and therefore only have one velocity, plus M2 V final. And we can take V final out here. And so we have M1, which is 5 kilograms, times its initial speed, 10 meters per second, is equal to mass 1, we can take out V final, and mass 1 plus mass 2, which is 5 plus 5 kilograms, and mass 2, 2 kilograms, and so we have 5 kilograms with 2 kilograms, 7 kilograms, and so we're left with V final is equal to 50 kilogram times kilogram meters per second over 7 kilograms, which just leaves us with meters per second, and so we're left with 50 over 7 meters per second, which is 47 1/7 meters per second, so that's 7.1428, so 7.1 meters per second.